Welcome to Backyard Philosophy, a podcast where a couple friends grab some cold ones, sit around the fire, and talk about science, philosophy, and history. Crack one open, sit back, and get a good laugh as we discuss everything from automation to why the meaning of life is 42.
The future. The polar ice caps have melted, covering the earth with water. Those who survived have adapted to a new world. Mike, today we're going to talk about sea level rise. And it's probably going to be our last Waterworld reference, unfortunately, but as you know the rules, when two drifters meet, something needs to be exchanged. We're going to talk about an exchange of information here, but before we get into that, Mike, how are you doing? What are you drinking?
I honestly didn't think Waterworld would ever come into existence, but boy, seems like I'm wrong. I'm doing pretty good. I'm drinking some gin and juice. How about yourself, my friend?
Just drinking the collection of beer left over from having guests. I got some Monkless Belgium ale, and then we're going to just drink whatever else is in the fridge. So sea level rise. Everyone's talked about it. Everyone pictures in their mind giant waves crashing over most major cities, women and children fleeing. But what is it? What has it historically been? We're not going to get into the entire past 100,000 years history of the sea level. I just wanted to bring up some quick points that, or little bits of information that I thought were interesting. And let me get it here. Okay, so during the Cretaceous period, which takes place about 95 million years ago, the entire central United States and the state of California was covered in water. And sea level was obviously higher than it is now, but that doesn't mean that that's normal. Sea level has gone up and down over the world the entire history of our existence. Our continents have moved around. I mean, at one point, Idaho used to be a jungle. There's fossils you can find in Idaho that you can still find in mainland China. And I cannot think of two different places than Idaho and China. But throughout history, about every 150 million years, it seems that there's a rise and a fall. You have a high level of CO2, global temperature, and sea level, and then it falls. And then you have a high level of CO2 and temperature, sea level, and then that falls. Starting, the data I'm looking at goes back to 400,000, a little bit, probably 390,000 years ago, and then it ends at the present, but our CO2 concentration is increasing faster than it has traditionally in the past.
Out of curiosity, Nick, for that data, is that, I assume, geology, like looking at rock layers, or is that like taking ice samples? I'm just curious. I don't expect you to know it. I was just wondering if you happen to know it.
So the sea level data comes from looking at fossils, and the CO2 concentration data, I believe, comes from ice samples. I don't know about the global temperature one, but I'm not completely sure about that.
Good to know.
So the sea level data comes from, there's two places. One is the Mediterranean, and one, I forget the other one, but it's a large body of water with a narrow inlet, and they look at for these certain type of fossils that, when they're alive, reside on the shore. And so then they can kind of see where the shore was based on those by seeing where they were at in the layer, in the geologic layer, and then comparing it to the other, the Mediterranean, and I wish I could remember what the other one was, but something about the small inlet, large body of water led it to kind of level out more so, be more stable than other areas. And we'll kind of get into why that's important later, of differing areas being compared to each other. But so I thought that was really cool, because who thought fossils were good for more than making new dinosaurs? Just kidding. I know that's not real, but
Well,
I wish.
we can wish.
So, one of the crazy things that I saw, Mike, I don't know if you saw this as well, that sea level rise 13,000 years ago would basically cover most like most sea level cities, so your New Yorks, LA's, thank God, San Fran's. Unfortunately, I don't know if it'd get to Portland.
Sounds like a simpler and better time.
And then you got it was definitely a simpler time. And this is what I thought was crazy. I don't know if you saw this. 14,000 years ago, over a time span of 400 years, the ocean level rose 65 feet, or half a meter for every 10 years.
That is amazing. I assume, if I had to make an educated guess, that has to deal with tectonic plates hitting each other, perhaps creating fractures in ice or something like that.
I think you had ice melt along with titanic plates, but that's sea level rise that you could like see every year. Like that is insane.
Talk about beachfront property constantly.
Oh yeah, completely. So I want to talk about kind of some of the causes, the geologic causes, and then Mike, you'll kind of take it into current causes of sea level rise. And so we'll start kind of the small and work up to the large, which is where Mike, you'll take over. Leaking. The oceans are leaking. Not a lot, but for those of you who don't know, there's about the same amount of water we have in our current oceans. We have that same amount underneath the mantle, and they slowly, over a bunch of years, move back and forth, and it's a pretty small amount. So for the past 200 million years, it's only changed the Earth's sea level 100 meters, which sounds like a lot because it's two big numbers, but 200 million years is a long time frame.
If I can jump in on the mantle part, I know this from other researchers. Scientists suspect that there is huge caveats underneath the mantle and of just water reservoirs, perhaps enough to cover all land like that's underneath the mantle. So there is a strong possibility. There is, I don't even want to fathom, get it, because we're talking about water. I don't want to fathom the idea of how much water is in the mantle. If it is, scientists are correct, and there is water there, that would flood the earth. We would all become sea people. We would all become mermaids.
So I saw just estimates because we don't know. The scientists basically look at rocks to try and determine how much pressure is down there, and some people say as much as the Earth's ocean, but I've also heard 3 times as much as the Earth's ocean, which seems just unreal to think about.
It's so weird. We know more about the planets in our solar system than we do what's underneath our feet. And for everyone wondering, like, why don't we just dig down there? It's really hard to dig deep into the earth and to break. I don't think we ever broke the earth's crust. So to get to the mantle, that's a tall order.
Yep. Speaking of things we don't know that much about, our next small effect, long-term causes, is plate tectonics. That would be plates. Everyone knows the continents are. All our land is on several different plates, and they're constantly colliding and moving apart from each other, which is why oh my gosh, what's the giant tall mountain in India? Or Nepal?
Are you talking about Mount Everest?
Yes, Mount Everest. The Himalayas, right? That's why they keep getting bigger and bigger every year, because plates are moving against each other. And as the plates move, sea level changes. Think of it like a cup, and you have a set amount of water, and you're making your cup longer, or you're making it closer together. Your water moves up or down depending on what you do to your cup. But that's about 0.01 millimeter a year, averaged out for another long frame of time. And another one that's in that same kind of time frame is adding sediment to the ocean. So through the natural process of erosion, that happens all over the planet. Wind hits rocks, rain hits rocks, makes
The
the
Grand
rocks
Canyon's
small.
there for a reason.
Things start pieces start to erode off, eventually fills in the ocean. Well, eventually, a long time ago, it wasn't all in the ocean, but you continually have a sediment layer deposited onto the ocean floor, which is you're kind of taking some sediment from not in the oceans and putting in the oceans. That accounts for, again, less than the plate tectonic shift. Then you have debris coming in the ocean. And I don't mean like, oh, I'm going to throw my empty beer can in the ocean. I'm talking about objects that get put in the ocean, such as islands, volcanoes exploding in lava.
Things that make warships look small.
Yeah. So, for example, the island of Hawaii, just by that being there, raised the sea level 3 centimeters. So each time there's an underwater volcano exploding that we don't know about, we don't see, it doesn't mean it's not having an effect. And now, I mean, now they map a lot of that stuff, so they kind of know what's going on. But you could also, it does have a pretty big effect, and you can cause it to drop either, like if one of those volcanoes explodes and is hollow and the water rushes in or something. So I'm going to give an example. Shit. In the past 70 million years, volcanoes and tectonic plate movement has caused a 30-meter drop in the oceans, which is pretty much canceled out by a sediment rise over the past 70 million years, causing a 70-meter raise. And these are all big numbers, but again, 70 million years. That's not a huge time scale on a geological scale.
It's not. And also, to add on to the volcanoes, the Earth is alive. It is constantly changing and adapting. Like in the Atlantic Ocean with the mountain ridges underneath water, there are literally live volcanoes underneath. There are plumes of black smoke being projected into the ocean. There are new ground being made through lava that's coming up through those vents. Those thermal vents are completely adding more to it, but like Nick said, it's quite a small amount.
Yep. And then finally, I think here we're going to start kind of trading off, Mike. We're getting into ice melt. And so ice, so icebergs, so ice that's in the water, they don't add to sea level rise, because if you have ice in your glass, it melts because it floats, it's less dense. When it melts, it gets warmer and it evens out. But if you get ice from the land that wasn't previously in the ocean, then that will cause the sea level to rise. When all the glacier, the ice fields melt, the earth, the actual ground, starts moving up like a sponge. It's got all this weight off its back, so it'll rebound a little bit. So that raises up the earth, but you're adding water to move it up as well. So there's a lot of stuff going on, is my whole point.
Yes, I think it's a big difference between ice sheets and icebergs. So, like Nick was saying, some basic science for everyone. So, an iceberg, I think that goes back to, I think it was Archimedes or Newton or someone like that, where a floating body in a fluid, it's equal to its weight. So since the iceberg floats, it displaces the same amount of liquid as it would when it's a liquid and not just solid like ice. So icebergs that are in the water, they're what already make the sea level rise as they are. They get broken off and fall into the water. That's a big no. That's a big uh-oh. Then you have ice sheets. So an ice sheet, this is kind of a poor example of it, but imagine a glacier. Imagine Greenland. It has, a lot of ice, a lot of cold in Greenland. And instead of having it break off and fall into the ocean, it gets melted and runs off into the ocean. That's a huge impact of icebergs and ice sheets. But again, icebergs, once they're in the water, as much as the water will rise as soon as it hits the water. And Nick, before I hop into why certain ice sheets and icebergs are melting, you got anything else about the history of the Earth has been changing throughout because of water and different effects that the water has risen?
Uh, I guess I don't want to get. I want to talk about all the causes before we get into, I guess, what's causing the causes.
Sure, let's go.
Does that make sense? Um, so one of the other things that contributes to the temperature of the sea level, which the temperature of the sea level is important because the ocean gets warmer, it expands because when things get warmer, they expand. And as plate tectonics move around, they can change the way the currents in the ocean move around. So when the Panama Isthmus closed, the Atlantic started becoming warmer. Not only warmer, but it became saltier as well. And it transported warm water to the Arctic, which cooled and sank, and it became dense as it sank. And that just added to the conveyor belt because eventually the ocean's conveyor belt, because you have that rapid heating and cooling, which a follow-up effect of that was an increase in moisture, and then that would fall as snow in Greenland and build up the ice sheet in Greenland. And I think we're going to talk about it probably later on, Mike, but do you want to say anything about thermal
This kind of goes
expansion?
with it, but it definitely ties in with the long time frame of Earth. A point that you might miss, Nick, because it has to deal with space, is the solar system's moving. Our sun is moving, and we're moving along with it. And if I'm not mistaken, every year we move some fraction away from the sun. So that might mean nothing, but you add a couple million years to it, it makes a big difference. So I imagine that's got to have a huge impact on our environment, and especially with asteroids, there's a lot of forces in play. That's what I want to add on there.
Yeah. And I think part of that, a direct effect that people can see with the way that gravity is pulling at our tides, the higher tides, or high tides are higher now than they have been in the past. And that's because of the moon and the solar system and all the weird effects of gravity that play such a huge part in our lives that we never get to see.
Which is surprising to me because the moon's moving farther away. So it surprises me that the tides are getting larger in that sense.
Yep. And then, so I guess the last point last little tidbit of information I had is that 20,000 to 7,000 years ago, sea level changed around an average of 10 millimeters per year, which is pretty high, but that was coming out of a ice age.
So the Earth tilting a different direction and melting all the ice that was frozen and pushing south.
Yeah. And so you get a lot, ice plays a huge role in sea level rise. And I think, Mike, you were going to keep talking about that because that was the last kind of immediate cause. Now I think you're going to talk about cause of causes.
Yes. But before I precedent that, I want to start in the 1880s. So, recording weather, temperature, coastal rise, sea depth, this is all somewhat new, especially in human history. I would say mapping out to a scientific degree of what's happening around us is in the past 200 years. And in the 1880s is kind of when we started recording the sea level, I guess is the way to say it. It's weird saying sea level, Nick, when it's the oceans that are rising. I don't know why it seems so weird to me. But anyhow, so in the 1880s,
Well, it's weird I live by the beach. The ocean is always moving. So it's hard, like, how do you define sea level? I mean, when you have low tide, you have to measure in a fixed point, which is what they do, but it's a very difficult thing to measure.
oh yes, and back in the 1880s, I can't even imagine how they were doing that. I imagine you just put a stick in the ground when things are calm and go, that's sea level. But we've been recording for it for the last 100 and some odd years. And in the last 100 some odd years, the sea level has on average increased over 8 inches. It's gone down, it's gone up, but overall has increased 8 inches. 3 of those 8 inches has happened in the last 25 years. And kind of coincides with the human boom, but we'll get into that later. I want to first talk about ice sheets and icebergs. So, Antarctica, a continent that I want to go to, but I would never want to live on. It is full of ice. Granted, it used to be a tropic zone when the entire world was combined into one supercontinent, but I transgress. When ice falls off Antarctica, the iceberg, that iceberg adds into the water level. It has a dual effect because in short term, if I remember correctly, it equals out nearly instantaneously because the cooling temperature helps deal with the swelling of the water, and then once it melts, it goes back to normal. I believe that's that. I could be mistaken. And then ice sheets. So ice sheets, you can have a field of ice. Now it can fall in and become an iceberg, but it can also just melt and run off. I mean, I imagine most people living in a cold climate can testify this, and Texans, you can testify this too, since it happened to you this past season.
It happened to you one time.
When you look outside and you see some icicles, and it starts to warm up, spring comes, sun comes out, all that water starts to drip off. Well, that water's got to go somewhere. And when ice sheets melt, something that large, that huge, it goes into the oceans. And that adds on to the oceans. Because ice sheets usually are on top of land or on top of other ice, which is on top of land. So ice can be attached to things underwater based on cooling temperature. So ice can build upon ice. So just because it's in the water, it's not technically an iceberg yet. It has to be like an island on its own. Like Nick said with volcanoes, well, when a volcano cools, it might create a space for ice to accumulate and grow upon and grow on top of. That brings to ice sheets. Another one, which I sort of talked about with swelling, is, well, water expands with heat. Like most things, like Nick said, heat makes things expand. And boy, there's a whole can of worms. I'm just going to name a few because we'll get into them later. But having holes in our own zone that allows more UV light coming in to quite literally boil our oceans, to have more CO2 go into our oceans to help expand it. Because for those who don't know, our oceans are our major source of storing carbon dioxide. The CO2 in the atmosphere is only a concern when the oceans are full of CO2, and nudge nudge, don't know. The oceans are getting kind of full of CO2. We'll talk about that in a bit. But I transgress. In the 1880s, we started measuring, and we measured about 8 inches from the 1880s to now. That's might not seem a lot to you, to people listening, but the oceans are huge. That's 8 inches of pretty much the entire surface of the Earth that increased. That's a lot of volumetric water being grown. And currently, right now, sea rise is about 0.13 inches every year. And, well, it's going to increase from that 0.13 inches because it is not a linear graph of the temperature increase. It seems to be almost like a x plus 1 increase. It's not exponential, but it is growing. And it is amazing to me on how much is going to affect the economy, the world, and the environment. It affects everyone. So I go back to thermal expansion. Water. It, again, heats up, it expands. And about half of the sea level currently, well, I don't know if it's currently, but the last 25 years sea level is somehow tied to the greenhouse gases it's getting absorbed. It might not be a full percentage, but it is a prominent percentage where it is tied into it. which is very interesting because, again, water is a good absorbent. It's not necessarily for solids like we were talking about earlier, where, you know, you have the water rush down, the wind blowing rocks into the water and expand that kind of way because by you're adding more solid mass. But sometimes the ocean expands because of gases. The gases are too heavy to be lifted out of the water. So it sits there and expands because it takes space. You know, matter takes up space. But we all started to notice something different going back to the 1880s. Right around the Industrial Revolution, this is when things start to change a little bit. Obviously, nothing really happened in the first 20 years. I mean, we'll talk. That's a conversation for another day with the cold, affecting the moths. That's a whole conversation for another day. But that started the okayness. That's the best word I can come up with for mass manufacturing. Which mass manufacturing has, I would say, saved so many lives. Like the Industrial Revolution is a direct cause to millions, if not billions, of people alive today. But unfortunately, it's a dual-edged sword. It creates a lot of pollutants. And for the longest time, we didn't care about what we polluted. We just cared about the end product. And before I get into that, Nick, I want to know if you have anything else to say or anything you want me to explain upon.
No, but I guess, to kind of put things into perspective for how much ice is in ice sheet, how much ice is in ice sheets right now? Are in ice sheets right now?
How much ice could an ice chuck if an ice could chuck?
So this is crazy, Mike, because you know how we've all seen the Great Lakes, and most people have seen on a map the Great Lakes. At least look at the map of the United States, that distance between Wisconsin and Michigan, that's all water. 1.2% of groundwater are distributed in lakes, rivers, soil, and swamps. 30% are in groundwater, 1.2% are in lakes, rivers, soils, and swamps, and 68.7% are in ice sheets. So that's how much water we have currently locked up in ice right now.
Let's not melt that because I don't want a beachfront property in Kansas. Can we just let's ooh. I didn't realize that number was that high.
Well, yeah, who wants to live in Kansas?
Well, if it's the only ground left, maybe everyone.
But that's all I really had to add on to that. I thought that'd help kind of give some perspective on how much ice we have right now. I mean, we have essentially a continent of ice in Antarctica, and we have a bunch of ice in the northern hemisphere too, which has changed throughout time. I mean, at one point, England was covered in ice, Michigan, all those states. Ice expands and contracts. I mean, where ice is located expands and contracts. But as of right now, that's where we're sitting, which is crazy to think about because even if you don't live by a Great Lake, you live by some kind of water source, unless you live in Nevada, in which case you don't know what I'm talking about. But if you live anywhere else, you live by some kind of water source. And I live by, well, I guess I live on the coast, but I also live by a bunch of rivers. And every time I'm like, man, that's so much water. But to think of that, so much water to me is only 1.2% of our unsalinated water is, it hurts my head. Not going to lie.
It's hard to put in perspective. And Nick, I got a good t-shirt for us. Ice belongs in my drink, not in the oceans.
This would be a bad time to talk about that time I used glacier ice to water down my whiskey. Not water down, but keep it
cold. No comment. But anyhow, with the Industrial Revolution brought new gases, new toxins to the environment. And being naive as a young industrial race, we kept doing the way things have always been done. Until we started to realize, oh shit, we kind of made a mistake. And we are now starting to see and feel some of the consequences of it. With the ever-growing rise of the sea level, which is kind of weird to think about. It's like a death by 1,000 cuts, the sea level. You don't really notice it until it's too late kind of deal. But as Nick said, and I still am trying to process the unfathomable amount of water percentage that's in a ice sheet form. I, I, yeah, I, I can't, I can't quite fathom that. I need like,
Well, I mean, I said at the very beginning, there's a point in our world's history where the entire middle of the United States was underwater. Now, we're not losing water or gaining water. That water had to go somewhere.
yeah, it had to go somewhere, but still to understand the scale of it is still I struggle with. But as we mentioned with pollution, it helps go into the water and helps heat the water. These gases, when hit with UV, expand. Because in case you don't remember from science classes, when gases are excited by heat or electricity or other projectile matter, and I can't think of the other one, but when they are excited, they expand. Well, if it's an average temperature expand, it helps the water expand. And water itself, hydrogen and oxygen, also expands. And I'll talk about thermocline in a little bit, but the upper level.
I'll explain it in fishing terms later, but I'm gonna applaud you, Mike, on not making a stupid joke about when water excites, it expands.
I'm blanking here. I can't think of a good joke.
When it gets excited, it expands. Never mind. All right,
Listen. I
moving
like
on.
some quality H2O.
Look,
But
it's a boner joke, Mike.
oh, okay. That went way over my head.
Well, apparently.
Hey, if the way the water rise keeps going, it's gonna go way over my head too. I mean, with warmer waters and a larger volume of water, it leads to higher rated hurricanes and typhoons, which the Gulf of Mexico, the islands and the coastlines have felt. The Oceania, the Australian continents. I can't figure out. I can never remember the proper term to call the islands, and Southeast Asia all getting hit.
Where the prisoners live?
Down under. But all those areas are getting hit with more massive tsunamis and hurricanes because, oh, not tsunamis, typhoons and hurricanes because of the warming waters and the amount of water. And I imagine, I didn't come across this in my research, nor did I go too far in depth in it. I imagine the El Ninos on the Pacific side of the Americas have also probably increased. I mean, warm water in El Nino causing a wave, more warm water. Could dilute it, I'm not quite sure, but I imagine it's got to add some type of effect to it. But as all these typhoons, hurricanes, floods, tsunamis, all coming together, countries are getting ready for a new lifestyle. Jakarta, I mean, they're building a 40 billion, 80-foot high seawall to help protect the country. They should ask Trump if they want, if they knew any good builders. No, that's a bad joke. Not a laugh out of you, Nick.
Build that wall.
God.
Build that wall. Keep those seahorses out.
You walk a dangerous line, my friend.
That's the first sea animal I could think of because I don't want to keep anything out that I can catch as a fisherman.
Starfish.
Seahorses just kind of bumble around. They're not. You can't catch them.
I beg to differ, but that's a story for another time.
What bait are you using to catch seahorses?
Goggles, snorkel, and fins.
Okay, so that's not fishing. That's snorkeling and stealing. That's actually very common in the part of the world we're talking about.
Wait,
Continue.
what's the difference between fishing and with your hands or fishing with a pole? Aren't they? You both get fish. You're fishing.
Tell that to the state of Oregon.
All right. Good.
One of those will put you in jail.
Good to know. I will.
And pretty much every state. The only state you can, I mean, you can do it in most states. You just gotta pay for it.
To catch a fish with your hand?
No, with the spear.
No,
with
I
the
meant like physically grabbing it.
well, I would have to look at the regs, but I'm sure they have something about that in
All
there.
right, going back. All right, we're in the water, but let's go more than waist deep. Da-dun. Uh, so countries are starting to spend more money on it. I mean, Jakarta, I don't think is exactly a rich country. I could be mistaken, but I don't think it's ranked in the top 50 of economics in the world. So $40 billion seems like quite a lot, but $40 billion to make sure all your people don't drown or your entire landscape gets destroyed seems like a fair price. And it's not just other countries. I mean, countries in the Philippines, other islands in the Gulf are doing it. America is preparing for it, and not just on a government level, but a business level. So, which is really weird to me, and I didn't know about this researching, but apparently for years, billionaires have been, well, and millionaires, but billionaires have been buying inland land where scientists project the coastline will reach within certain lifetimes. Like they're preparing for it. They're buying land inland. And just to give you another number that is, again, kind of hard to imagine because it's a large number, but about 10 people, no, sorry, 100 people in the United States, 100 millionaires slash billionaires, have bought over 42 million acres of land in preparation for coastal line rise. That's like a state, right? How big's Maryland? That's like an entire state they just bought.
Maryland's a big state. What's New
Rhode
Jersey? Is
Island?
that small state?
Rhode Island's the smallest one,
Rhode
right?
Island, New Jersey.
No, Rhode Island's smaller than New Jersey.
All right.
But speaking of Rhode Island, New Jersey, and Maine, they are all also preparing. For some reason, the Northeast is getting more affected than, well, that's a poor choice of words because Florida's getting fucked over quite hard by the coastal rise. But Northeast seems to be able to see the impact the earliest, I guess is a way to phrase it. So in 2005 to 2015, the average cost for 8 coastal states to help combat and prepare for coastal rise was $14.1 billion. Those are states. That's how much that everyone is worried about this on a large scale. And boy, I since I talked about Florida, but hang on, before I get into Florida, because Florida is its own monster. Nick, do you have anything to add in or want to ask about?
No, but that is buying more land than the state of Rhode Island.
Is it really?
Rhode Island is 1,214 square miles.
How's
Nothing.
Yeah. I mean, God, I feel like I drive.
I work for a company that I think owns more land than that state.
That's so weird to think about. Oh, that's so weird. But with God, well, speaking of land and trying to preserve it, Florida, the Venice of America, is a sinking instead of city is a sinking peninsula. Florida is damned if you do, damned if you don't. They get it from all sides. Invasive species, iguanas undertaking housing market, just now coastal floods. It's just Florida. I don't know how you survive, but you're still surviving. It is quite impressive.
So to pile on Florida, the Florida has a elevation range less than what I walk on an average day, going from 0 to 345 feet. So they have a lot of land that's at risk for flooding because they have no elevation gain. Like I said, on my average day, I will do a climb of greater than 400 feet. Their average elevation is 20 feet. And it's a great indicator. If you look at past pictures of Florida for sea level rise, within a period of 7,000 years or something ridiculous like that, Florida has gone from double its size to half its size just based on where the sea level is at. So it is the most at risk because it has no elevation.
It almost seems like a betting game. Who do you think is going to get destroyed first? California from earthquakes, tsunamis, and wildfires, or Florida from iguanas, pigs, and floods?
So you forgot, I think California is California's greatest enemy. Florida has to fight nature. And if I had to fight a Californian or a Floridian, I'm going to fight a Californian.
I would also do the same in that fight. But it's not just United States preparing for it. I mean, granted, 8 states spending $14.1 billion in the span of a decade, that's impressive. But other countries are trying to literally raise their entire cities. The tomb, or is it the city of Cleopatra in Egypt, they're trying to save. Venice is a fighting battle, which I am not quite sure if it's worth the effort they're putting in. Granted, I want to go to Italy. I want to see the sights. I want to see the cultures. I want to go to the festivals. But it seems like Venice is au revoir. It's nearly gone. And to go back to Florida a little bit, Florida, yes, is extremely flat, like Nick said, and it's not really high in elevation. Its ground is very different than more inland ground in the United States. The ground in Florida tends to be less clumpy. It tends to be more loose, I guess is a phrase to say it. And like Nick said earlier in the podcast, when you have water moving in and out, tides, wind, you get more land erosion. And if the ground's not tightly packed together, it's easier to erode. So, again, this is a larger scale. I'll go back to Florida in a second, but when the water is supposed to rise, right? It's supposed to rise, I believe, by 2050, another 6 to 10 inches. You're like, oh, well, my elevation's 20 feet above the land. I'll be fine. It's not quite like that. It's not like Minecraft where you place a block next to it and a water next to it. It's not like that. The water will slowly steal the land out. It will start flattening it out more, so the ground will start to sink. And not only that, another thing with Florida is it's at risk for all its fresh water. So all your fresh water can be gone. All your land can be gone.
So Florida, the rock underneath Florida is a porous limestone. So if Florida's like, we're going to prepare for sea level rise and build a giant ass wall around Florida, it wouldn't do anything because the groundwater, the rock underneath the state is so porous that if the sea level were to rise above the sea level and there was a wall there to not let it in, it would just come up underneath because the ground is so easily penetrated, which would make it salt water instead of fresh water. Even though Florida has a ton of natural aquifers and stuff like that, as soon as the sea level rose above a certain point, it'd penetrate right through any groundwater that they have above that elevation.
And Nick, I don't know if you know this, but you shouldn't drink seawater. Salt water is kind of bad for you.
Just a little bit.
Just a little bit. So,
but that little bit when you're swimming in the ocean, you lick your lips, you get all salty. Oh, it's the spot.
Please never say lick your lips and salty in the same sentence like that ever again.
You eat pretzels that are all salty and you lick your lips.
Stop. Please stop.
That's the spot. All right, this is a great spot to get to a fake sponsor, Mike. I would love to get a Babbel sponsor and you take the English course.
Honestly, I need it. I wouldn't be. I honestly need it. So I'm okay with that.
All right, I had to say that before.
It's a good one. It's a good one. All right, so we have some quick numbers of how much it's going to affect the economy. Some things to think about. I think 1 in 10 people live in low elevations. So as soon as the water rises, Adios. If I remember,
That's me. I'm those 1 in 10 people.
and then
My house is located at 26 feet
get
above
that
sea
kayak
level.
out and get it ready.
But all I need to do to get out of the tsunami zone is walk up my driveway to the road. So I am 20 feet away from the tsunami zone.
Well, not just 1 in 10 people like Nick who live in low elevations, but I believe correctly, it's more than 90% of the world's population lives by some body of water. And so you're like, well, the coastal rise, it's rising just the coast. Well, it's not just rising the ocean coast. The coastal rise is also rising, I mean, all water levels. So a way to think about this is with more vicious storms, they push more inland, so they bring more water into there. There's more more evaporation brings more rainfall, which doesn't necessarily dilute the amount of water level in the sea, but simply brings more water to other areas because it's almost like a middleman almost. The ice sheets run off into the ocean. The ocean then sends the water inland, and it all balances out the end where it both increase. So water is increasing on all fronts, which is quite scary. But 1 in 10 people might have to. This is the world. This is 7 million people. 1 in 10 people might have to leave their homes to go somewhere else. And God, not to mention all the docks, piers that need to change. But before we get into the problems with it, I want to talk on causes. I got away from that. I picked on Florida for a little bit. Go back to causes. Again, I think from my research, the biggest cause is simply humans. Like Nick said in the beginning, the Earth changes. It's constantly moving. It's dynamic. It's not static. Granted, we don't live long enough to really see it with our human eyes, but it is. Seas rise and fall. Things come and go. Things erode and build back up. But to have it at this level in our lifetime, or that much effect, humans have a huge part to play in it. It's not the full picture, but they, I would say, are the foreground of the picture. Our emissions, and emissions isn't the best word choice for it, but it's the only one I could think of. Our emissions can not only help melt the ice, which then both the ice sheets and icebergs, which then increase the water level. Are, like I said earlier, with our gases entering the water, expands the water, and then burning holes through our ozone, which then increases the UV through the atmosphere, which then also heats up the water. So it's all not very good. And then it goes, of course, poor land management, which makes the soil loose, doesn't have deep roots, and gets completely destroyed. Not to mention all the early days of construction in the United States where it was destroying fronts and which kind of make areas swamp, bogs, and terrible locations now. They're just on the brink of being destroyed and flooded. For example, Boston. Good old Boston is at very risk. I would say about the same level as Florida of being fucked by the coastal rise.
All right, now I don't know a lot about Boston, but are you referencing to all the corrupt cops?
Nah, you gotta
Or is that just a Mark
no, you
Wahlberg
gotta park
movie?
the car by the
Mock
harbor. The harbor's the problem, Nick. The harbor might be gone. Oh God, we're gonna piss off a lot of Massachusetts people. But, uh, but Boston's like another Venice in America. It with the coastal rise rising 6 to 10 inches in the next 30 years, Boston might be gone, which is really weird to think about. Like in our lifetime, we might see cities disappear. If I remember correctly, there's like 25 entire cities at risk. Entire cities. That's millions of people just gone. Entire industries gone. Entire economies gone. Entire history gone. It's like underground cities might be a more common thing. God damn it, Waterworld might have been right. It's a terrible movie, but it might have been right.
Okay, well, first off, I don't think Waterworld was that bad. So, but the other part is when you're saying hundreds of people will be gone, they're not going to be gone. They're just going to move. Like, this isn't an overnight thing. This is a yearly thing. No one's going to get swept away, like and die of sea level rise.
Well, let me ask you this, Nick. Would you rather stay in the flooding zone and just get swept away by the waves, or move to Kansas?
Well, I don't live in the flooding zone because I choose to. I live here because I can afford to. So,
Well, I imagine most people don't want to leave their homes. Most people are homebodies, and I imagine a lot of people will fight to the end, but they are at risk. And like Nick said, they will move, and they will fortunately move inland where there's going to be a lot more people. But again, I don't think anyone's up for debate. Humans are having an impact on the environment. It tends to be more negative than good. But we're learning from our ways. We're trying to fix that, and we have some solutions and some cool solutions we came across that we'll talk about in the podcast. But Nick, I think this is a good point for you to hop in because, well, farming is being heavily affected by urban environments and more people moving inland and more billionaires and millionaires buying more land inland. It seems like a lot less land and a lot more people grasping at it. So, what's your thoughts and opinions on that?
so one, I have no idea if this is related to Bill Gates by becoming the number one landowner in the United States for farmland, but probably is. Second, like we talked about in our overpopulation episode, more people, less land leads to tensions. And second, you have more people moving onto fertile farm ground, which would be better spent growing plants than it would growing idiots. But I digress. I'm sorry, Montana, that you now have to host Californians instead of cows.
The worst plague.
It is. It really is. And I live in coastal Oregon, and we have some super fertile land. Luckily, it's so steep, no one wants to live there, and it's very similar to this whole issue, right? Because our ground is steep and it's a sandstone, so our ground's not very stable. Now, people still choose to live there, even though they know there's a very that's a good question if they know or don't know, but either way, there's a very high chance that the steep slope they're building on will at one point slide out and their entire house and possibly them will get destroyed. But there's something about living on the ocean, right? There's something about living in those beautiful places that it's worth the risk to maybe lose everything. And it's not just people who live right on the ocean. I myself do not live right on the ocean. I just live in the fog belt. And so living in Oregon on the ocean is not the same as living in any other state close to the ocean. It is cold and foggy here. It is not warm and sunny like you would think. But I think it's going to create more tension. And we touched on an overpopulation episode. And I think we also kind of touched on this in the coral reef episode of building near the ocean. Now, as the ocean comes up, those houses are still going to be there. And like we talked about, oh my gosh, we're going to have to cut some of these plugs. This is embarrassing. In the wildfire episode, people's houses are full of gross shit. I mean, gross shit for the environment. Everything from your bleaches, your household cleaners. I mean, it's Florida, so there's ammunition in every single one of those houses.
Cocaine.
Probably methamphetamines. Bath salts, they're
throw it
all in there. But just the shit that's in people's houses. And one of the number one destroyers of reefs is the concrete runoff. No, when you have a new development and you don't control your runoff from your new development, yeah. And so as sea level rises and we need to start kind of letting go of some of that land, now how does that go? Because no one's going to give up their oceanfront property. We're Americans. We don't give up land for shit. We'll take it if we have to.
Nick, I'm happy you brought up the coral reefs because along with the water being expanded by heat, it's also killing the coral reefs, which is also moving the fish. Warmer waters necessarily doesn't mean a healthier population of fish population. Waters might become too acidic, the fish might need to go into colder temperatures. Surprise, surprise, fish are kind of reliant on temperatures. And that means huge fish migrations, which means some poor countries won't be able to fish because they can't go into the deeper water or reach the depths. And Nick, that also means when you go out kayaking fishing, you might not catch anything.
No, that's not what it means at all, Mike. What it means is, well, most of the fish I fish for survive in far warmer climates. But what it really means is if current trends continue, tuna are getting closer and closer to the Oregon shore as they migrate north or more north and closer to shore every year, which means I might not have to travel down to San Diego to fish for tuna in my kayak. I could fish for tuna offshore in Oregon. And that is the dream.
Is it bad? I want to see you even attempt to fish a tuna fish in a kayak.
I don't call it the Nantucket sleigh ride for nothing.
That's an old man in the sea kind of situation there, Nick. A tuna fish in a kayak.
Oh, it's been done tons of times and it'll be done again. And I'm going to do it. And global warming is going to help me get there.
Although the climate change might have helped Nick, it doesn't necessarily help everyone else. Again, huge fish migrations. It changes the fish patterns, changes how people catch fish. A lot of people will starve. Just what it is. It's facts. And I kind of like fish. I don't want fish to kind of go away. Again, like Nick said, I think Nick said perfect. There's disgusting stuff in people's houses. And that's all going into the water. That's a bad time for the environment. But Nick, since we brought up big fish like tuna,
to add on to the disgusting stuff in people's houses, the material we use in our houses today compared to like 50 years ago, there's so much plastics and shit in our houses today. Your house will catch on fire like something like 200-300% faster because there's no natural materials in it that retard heat, retard fire. It's we live in tinder boxes, so the amount of time it takes for your house to burn is significantly increased just because there's so much plastic in it. And I didn't look this up, but plastic's generally not good for the ocean, and I feel comfortable saying that without research.
I'm pretty comfortable saying plastic's not good for anyone. But Nick, since you were talking about tuna fish, something that's else in the ocean that's also really big that has a huge impact on the ocean levels, because I don't like saying sea levels when it's the ocean levels, and it's also a mammal. Care to take a guess?
We talking about whales, or are we talking about seals and sea lions?
We are talking about whales. Whales are surprisingly really good at taking CO2 out of the ocean, or at least absorbing it. And, well, as certain countries kill whales, they release all those CO2 into the ocean.
Care to name those countries?
A study, I do not want to get kamikaze, so I'm not going to name those countries. A study in 2010
don't want to be sneak attacked.
God damn it. A study found that before industrial whaling, population of whales would have sunk between 190,000 to 1.9 million tons of carbon per year to the bottom of the ocean. Now, I'm going to explain why that's important in a second. That's the equivalent of taking 40,000 to 400,000 cars off the road each year. And again, the reason why it's important that they take it to the bottom of the ocean is temperature, which we'll go into. But whales are deep divers. They go for the air for surface, go deep in the water. They usually only travel surface with their calves or traveling for mates, if I remember correctly. I am not a whale scientist, so don't quote me on that. But since we started killing the whales, and I loosely say we, experts have believed, they believe that between 66 and 90% of the whale population is decreased. That's what they believe in, stuff like that. But all that carbon gets transferred up to warmer upper waters and then expands more and fills more. When it's cold, it stays condensed. Like we said, heat makes things expand, cold makes things condense. And it's also much colder at the bottom of the ocean than is at the top. So, I can't believe I have to say this, stop killing the whales.
Caleb.
Yeah, Kyle, stop killing the whales. But yeah, that's a pretty
I
easy
feel like
solution.
there's, not that I'm advocating for whale killing, I feel like there's a lot more things that influence the carbon cycle than whales.
Oh, absolutely. That is a drop in the bucket. But everything adds up. And we mentioned with the cold water, the thermocline. Thermocline is kind of like the temperature for the water. So at the top, you have, and excuse me if I butcher this scientific term, I can't speak English, like Nick likes to point out. The epipelagic zone is the top surface of the water. It's like 600, 700 feet. The top surface of the ocean. That's usually the warmest. Then you go down, you got this. I guess the best way to describe it is it almost looks like a parabolic curve, but at the top of the curve, it's a straight up. So you cut a bell in half, and instead of having and then have that top
All
half
right.
go straight up.
So
That's
we're going to break this down for you, Mike. The epipelagic zone, that's your that's
that's
your
the
area
word.
where light still penetrates. That's where you have most of your diversity at. Then you have your mesopelagic zone and mesopelagic zone. That's where your stuff that doesn't need light lives. And then your bathypelagic zone, and that's where your stuff that doesn't get light. And finally, your benthic, and that's your really deep sea shit. But most of your diversity, most of your everything we humans really care about is in your epipelagic zone.
Oh, I disagree with that statement. Have you seen the creatures in the Marianas Trench or giant squids? Those are fucking awesome.
Yeah, but have you seen like let's all right. Let's what the fuck was that documentary about oceans? 95% of it took place in your photic zone, which is your smallest
Oh
part of
yeah, yeah.
the earth, the whole thing. That's where all the most diverse life is. Yeah, the benthic zone is super interesting, but no one cares. Like that's not no one,
Oh,
but that's not what people want to see.
oh. A man can dream. A man can dream. But it's kind of simple. The cold air sinks, warm air rises. Ocean, it's kind of similar. Sun doesn't penetrate down that deep, so it's colder at the bottom, plus also pressure and all that fun stuff. It's colder in the bottom than it is at the top, and that kind of makes a big difference. So when you have those cycles, which we'll probably talk about in a bit, of carbon going down to the bottom of the ocean instead of staying at the top, it helps keep the overall volumetric size of the ocean smaller than larger.
So less less transfer of heat. You're saying, but eventually it'd warm up. So essentially, we're talking about what we were talking about with the in coral reefs when we were talking about how to keep the ocean cooler using making like ramps essentially change using some kind of infrastructure to change the ocean currents to bring the cold bottom of the ocean water up to the top to keep certain sensitive areas colder.
Yes. And Nick, I think you're getting a little too far ahead. I have one more thing to say before we start getting into
Copy.
solutions. Another one, which is kind of more of a United States problem, the rest of the world problem, but it will affect the rest of the world, is with the coastal rise. It affects military bases. There's a large percentage of military bases that will have to be relocated and moved to non strategic positions, or at least less strategic positions, because of the coastal rise. I don't. To me, that was fascinating on how the chessboard might change, so all the pieces have to move.
Well, you got to have easy access to move. I mean, being mobile is one of the greatest strengths a military can have. So the ability to quickly deploy, quickly launch ships, planes, whatever, is key. So, if you have to change that and move inland, which first off should be pretty easy because if there's anyone who can get money, it should be the military. I don't know if it is or isn't, but you'd think that'd be pretty simple.
And before I hop into solutions, this is kind of a tying in, and feel free to interrupt me, Nick, but living shorelines versus non-living shorelines. It's a solution and also a thing that's already found in nature. So, like we mentioned with erosion, again, as the oceans rise, it takes more of this land away. It also forces the land and carves at it. Well, live shores, which is our plants with deep roots, plants, trees that kind of tie in and keep the ground together, kind of tied
You
together.
talking about
Are very good
trees,
at
Mike?
Dude, I've been all over the board. Don't worry, I'll get to space. This is Coastal Rise is a huge impact on every aspect of science. But yes, Nick, I am talking about your favorite piece of science, trees.
Some might argue the most important piece.
I think you are the only one who would argue that piece.
Tomato, tomato.
But we have different types of shores. We have a living shore, which is pretty much just, I guess, think traditional like river shore. You got cattails, long grass, roots, mud, dirt, that whole thing. Then you got vegetation only, so think just lily pads and reeds, not really a smooth transition, kind of a cutoff. Then we got edging, which is pretty much just a mud wall. It's just clay, just not. It's just natural, just kind of making a barrier. Then you got man-made stuff, which is sills, which I believe I'm pronouncing that correct, which is wooden barriers. So people putting logs, which people have been doing for a long time. In fact, the river right next to where I live, they are replacing their sills to help keep the water levels down. Then you have rook walls, which are, I believe, like break walls, if I remember correctly. Then you have, oh, no, not rock. Sorry, can't read my own notes. Rock walls. So, but instead of a rock wall traditional, it's patches. So imagine, you've probably seen, if you've ever seen a coastal picture, you have water breaks. So if a large wave comes, it hits at multiple points, so it softens up the water. It's the same thing with the coastal rise. Then you have an entire rock wall, which is exactly what it sounds like. And then you have a bulkhead, which is what Jakarta's doing. And they're building a physical tall wall. Again, they're spending $40 billion on it. And I feel like I've been rambling on about walls and coastal line. Nick, please save me.
All right. So for solutions, Mike, this seems pretty familiar to you, doesn't it? I feel like we talked about this same concept in the fire episode of we know there's a danger and there's a unwillingness to adapt to said danger.
It does. But I think we are adapting to it. Well, surprise, I think Alabama might be leading the way in smart decisions, which, I'll be honest, was not a sentence I ever thought I would say in my life. So, like I just mentioned, listed off with the vegetation wall, the rock wall, Alabama's kind of doing a transition between all of them. They're doing like a step cage system. So the first layer being like a bulkhead, and then it breaks down into like a rock wall and then into a vegetation. But then they fill it all with mud and make it more natural, so that makes it all a vegetation. So it's almost like a transition era. So you do one step, do the next step, do the next step, and then completely you're done. It seems like a quick solution and a long-term solution, because the other thing with the vegetation solution, it constantly rebuilds itself. So if a massive storm happens and you lose part of your wall, the plants will regrow. If a storm happens and you lose part of your bulkhead, some of your man-made wall, that's gone. You got to replace it. So there is some strong benefits to having a vegetation wall versus a normal wall. And it seems like Alabama is leading the way in having a transition between the two of them.
That is a surprising sentence. Something that I thought, yeah. So you have, if you want to build up your beaches, you can do that. You can use machines that'll pull up sand and redump them along the beaches, kind of a temporary solution. But I think humans, we need some kind of economic incentive, and it's the same thing we talked about with fire. We're not going to change unless it hurts our wallet, right? I mean, it's beachfront property. We're not going to give that up. I mean, If I could afford beachfront property, I imagine I wouldn't get it up. But I think one of the biggest things that needs to be done is insurance companies not need to start charging more for that beachfront stuff in that danger zone of where your house is in danger, whatever, either from coastal rise or because of sea level rise, some kind of flooding. Because humans aren't going to respond to emotional, uh, I don't know, but arguments. No one's going to move because they're scared of sea level rise. Or, I mean, yes, to be fair, if you have a house on the beach, it probably doesn't matter that much to you. You can probably just buy another one. So that might be a whole part of it. But I think the solution is some kind of economic incentive. And my question is, Mike, to you, of people choose to live in dangerous areas, not just, and I'm not just saying people who live in areas of sea level rise. I'm saying people who build their houses in the middle of a thick forest when they know wildfire is present. People who build their houses on a floodplain. Nature doesn't give a shit about any of us, and we continue to build houses in places where nature can just tear it away. And how much of that is our responsibility to protect our fellow humans from this danger when, I mean, we know about coastal rise, we know about flood zones, we know about wildfires, we know what areas are prone to them. At what point do we say, hey, you can live here, that's fine. These are things we encourage you to do. You know, build your house on stilts, make it really tall, stuff like that. But at what point do we say, we're not going to waste resources and lives trying to save you during a hurricane? And not that every single person who's in a hurricane is going to die. It's far from the truth. I mean, hurricanes are parties to Floridians. They get to enjoy not being at work. It's honestly sounds like a really good time, and I'm very jealous. But I'm not talking about most Floridians. I'm talking about the people building houses in the middle of nowhere in the beach, and we're sending helicopters that burn expensive fuel out to get them. And I'm not saying we shouldn't save people. I'm just saying, at what point do we say, hey, the risk of you living here costs the taxpayers more than you give back, which again is unlikely because they probably pay a shitload in taxes. But is there something there to some way for those people to acknowledge the risk, Mike?
I think yes. I think you should live where you want to live. But if you do that, you must accept the risks. So if you want to live in a dangerous zone, so let's pick on Florida some more. So imagine we'll have the outside the coastal line being red, call it a danger zone. Inland being
Danger
orange and
zone.
yellow. You keep doing that. You keep color coding Florida like that. And purple. We'll say those zones, the sandbars are purple. Those are kind of like, those houses are fucked. Like, you know, if a storm comes, they're going to get gone. You can live there, but the city's not going to pay for gas line, electricity line. You want to do that, you got to do that all yourself. And if something bad happens, we're going to move our resources somewhere else and focus on that material instead of you. If you want to live in the middle of a jungle, you want to live in the middle of a forest fire area zone that's heavily dense, you're American. Do what you want. But you got to pay the price. It means if something bad happens, you're also on your own. We warned you. I mean, you tell a kid the stove's hot, you can only tell them so many times so they burn themselves. Sometimes you got to let them burn
I
themselves.
burned myself yesterday. The same exact scenario.
Oh God, Nick, you're special. But yeah, I as an individual, we're usually smart. As a masses, we're usually dumb. So maybe as a masses, we tell people, hey, don't live here. But as an individual, you could fill out some paperwork and jump through red hoops, and you can live there. But the risk is all your own, nothing else. Like, I imagine there's got to be some zones where even insurances won't cover. Or God, you have to pay through the roof some extreme premiums for the insurance. But there's got to be places where like insurance are like, nah, this is dumb. If you want to do that, you got to pay out of your own pocket, and I'm okay with that. Granted, I don't think we should advocate that, but you live your life.
There's another solution that I saw, Mike, that I don't think many people will enjoy, but big ass dams. I don't know if you saw that.
Is it? Well, maybe. Is it the one with?
Basically, cutting off the English Channel, keeping everything northeast of England, with the building a dam like from France to England, from England to whatever European country is there
So like a Pacific Rim wall?
in the Atlantic. Yes,
Yes. You ever seen the movie
no,
Pacific Rim? Never mind. My analogy doesn't work.
but they could build that for like 500 billion euros, and I have no idea how much real money that is, but it sounds like a lot.
I think the euro is actually less than the dollar bill right
Okay,
currently.
so say it's half. That's 250.
No, 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 no,
No,
no,
I
no.
know it's
Like
not
it's
half, but just
euro.
hypothetically, $250 billion. That just seems like a lot of money, but I could be mistaken. Inflation, all that shit. Um, that's a lot of money, but they could technically preserve their coastline and keep all that real estate there. It would cost a lot of money. Now, traditionally, dams have had arguments of blocking all sorts of marine life. Migrations been very the environmental community's been very against dams, so I don't think it ever get built just for that reason alone, but also because the price, who would pay for it. I mean, you'd have to get multiple countries working together for a common cause, and then you have to fight your environmental groups, so it just isn't going to happen. But it's an interesting idea.
It is. I actually didn't come across that. I came across a different scenario. This one might be a little bit more outwardly. Yours seems somewhat in the realm of possibilities, so I want to stick with the realm of possibilities for a second. One of them, which you kind of mentioned on Nick, was one of them we talked about in coral reefs, which is pumping cold water to the surface. You use a pump water from the top to the bottom, bottom to the top. It would have a huge effect. It seems not the hardest to implement, and we could probably get some of the energy back by using the water flow from the pump. So, seems possible. Granted, I don't know how many we will need, the distribution of them, nor what temperature ranges we're working with, but it does seem like a good possibility that's not too extreme for our imagination. But extreme for imagination is almost like a water reservoir. By dam, I thought you saw the proposal to, well, for lack of better words, sacrifice a desert. Kind of dig out a large landmass and let the oceans flood into it. So, like, the Sahara Desert. You dig a giant hole. You drop some Moab, some hydrogen bombs. You make a giant hole. And then you let it fill up with the water from the oceans. And that takes care of that problem for a moment.
That's true. That's so, and we may need to cut this. This is a dumb idea. Didn't do any research. Just off the top of my head. So one of the big reasons a temperature rise as ice melts, that ice that was white that reflected so much sunlight is now, well, it's now ground, so it absorbs sunlight. What if we painted the top of every building white? We could reflect a lot of sunlight from the earth and probably save on heating bills.
We're starting to do that. That's becoming a very common practice for construction
Okay,
businesses.
so I'm a
Uh,
genius.
yeah, that's actually a real thing. White paint is becoming much more common for top of buildings and houses and roofs. It's using basic physics of light reflection and deflection to help
Oh,
cool the planet. That's actually a real thing, Nick.
well,
And
it's
it's
a good
actually
time to
happening.
work for Sherwin-Williams. Anyway, so you got that. But then, yep.
Oh, if we're gonna talk about some crazy ideas, Nick, I got some crazy ideas, but I don't know if you're ready for that. I don't know if you have something else to say before we
Um,
start get
Give
way
me
off
30
into the
seconds. Let me
deep end
see.
of the pool.
I mean, I think the
No, no joke.
oh,
No,
God, I didn't get it. I did not get it at first. I'm not gonna lie. No, I mean, I think it's so. Personally, I think sea level rise is something that it's just another part of nature. Humans have a hard time understanding nature changes, and I think there's going to be a lot of people surprised when the sea level rises, even though historically the sea level has risen and fallen. And it kind of makes you wonder of would we? I mean, I'm sure we would have, but would we have developed all our major cities along the coast if we had known, say, the past 250 million years sea level levels. I mean, the only time in the past 400 million years that we got past our current level of sea level height was, give me 30 seconds.
Well, I'm going to say no because it's not in our perspective. A human lifespan's too short. If it's not in our lifetime, we don't quite understand it.
And I completely agree. It's just hopeful. So the around 125 million years ago, that's the only time sea level was 20 feet or 20 meters above what the current sea level is now. But if we had,
That's a lot.
it is a lot. If we had known that, would we have changed? And again, I think you're right. We probably wouldn't have. We have deceptively narrow views of the world for one of the most, not one of the most, but one of the more longer lived organisms on Earth.
We're such a wise species, but so dumb. But speaking of dumb ideas, I came up with a few solutions. Well, I should talk about geoengineering before I talked about my dumb ideas, because their ideas are also ludicrous, which makes me happy as an engineer. So geoengineering is a field which is pretty much a engineer who's trying to affect the environment. And they have some wacky ideas. One, kind of tying into Nick's white paint idea, is solar radiation management. It's pretty much turning down the sun's emissions. And that's right, I said that correctly. Turning down the sun's emissions. Like releasing a bunch of mineral dust into the high atmosphere to block out the sun for an X amount of portion. Floating blimps with mirrors to help reflect the sunlight.
I was wondering. It's like, I think he's saying blimps.
Yeah, I'm special. Definitely special. But yeah, those are real ideas on the table. The idea of launching mineral soil above me in the upper atmosphere, just something about that much dust in the air just doesn't seem like a good idea to me. So I would like to counteract with some other possibilities that perhaps are less crazy. One being salt removal. Well, that's a crazy idea that's on the table. I got one for you. Salt. The oceans, the Pacific, Atlantic, Indian, Arctic, right? 4 oceans? Yeah.
I think there's seven.
They
seven
are
oceans?
all. Nope, that's continents.
Yeah.
It's not potato. You can't do that one for continents and oceans. Those are very different. But all the oceans are salt. They're salt water. They all have sodium chloride in them. Sodium chloride is a molecule. That molecule we can easily take out. That's mass gone. We could have a massive evaporation process to reduce the amount of salt in saltwater oceans and simply just store the salt, I don't know, in Utah. They got enough salt. Why not add some more? We could add that salt to a different location and simply lower the water level that way. I imagine it's got to be about the same cost of sending dust into the upper atmosphere to block out the sun. Can't believe that's a real thing on the table. I love and hate it at the same time.
So, yeah, you have, so that would be essentially like you're being saved by salt and vinegar chips, is what we're kind of down to.
Oh, now I'm hungry.
Well, you should have eaten before the podcast, Mike.
Well, speaking of another crazy idea for you, it has to deal with soil, Nick, which is you love, but it also has to deal with material science, which I kind of love. So it would be soil that's not soil. It'd be synthetic soil. We would make a new type of compound that's harder, well, hopefully not like plastic, but plastic comes to my mind, but a compound that helps hold the ground together so we could have like a water-based plant so that it just holds the seed in place, but the roots kind of really solidify it. But that soil makes it harder for the water to erode, the wind to erode. It's almost like a bulkhead in a live shoreline.
So you're using invasive species to prevent erosion of beaches.
No.
Well, you need something.
Not the plants.
You want so
I
you
said the soil.
so you're going to use some synthetic
Synthetic
material.
soils. Yes.
This seems like a worse idea. I feel like this is how we got
It,
here.
I don't know. I mean, it definitely seems like a bad idea, but it also seems like an actual solution. So like having like a quartz based mineral that you turn into beads to and then just dump on the ocean fronts because it quartz is harder than silica, so it protects it longer or something like that. Or take a carbon based material and do the same thing. Just replace the soil that's being lost with synthetic soil to help prevent more soil erosion.
So I don't think that'd happen because one, you're removing beaches, which is a major driver of tourism. Most villagers wouldn't let that stand, but what they probably would let stand is if you establish some kind of use whatever material you're talking about as like a breaker, like a barrier reef kind of something to stop waves as much,
Question.
and so that you have less interaction with the water on your shore leads to less erosion overall. So if you can slow your waves down, you reduce erosion.
Question. Why would it ruin beaches?
If you have giant pieces of quartz on your beach,
No. Like I said, we turn them into like sand based, molecule based, we synthetic soil, so like soil size.
so you'd crush it down so it's essentially the same size as sand.
Well,
That's what you're saying.
I am yes. I imagine we would take a material and either chemically grow it or use a batch process to produce it and then dump it in place. It could be about the same size as soil, but we could make it the molecules a little bit more different structure shaped so they lock into each other better. They clump together better. They are either more dense so they don't move away as fast, or simply the shapes are more hooked like so they could latch onto each other to help each other from preventing to pull away compared to the silica based soil, which is a lattice structure, if I remember correctly. So it's kind of smooth.
So I think the main problem is you're going to face a lot of backlash from dumping anything onto a beach, no matter what it is. Okay, I kind of see more what you're saying now. I just pictured like the quartz they use. No,
Giant
just like the quartz
boulders.
they use for like road construction, just dumping that on the beach because that's simple, it's available, it's cheap. I foresee an argument over because you'd have to do it to all your beaches, right? It would have to be extremely cheap and extremely low emission. Otherwise, people be like, well, you're just going to spend more in emissions than you are going to gain from the raise of the sea level, I imagine.
Yes, it does seem like a band aid solution, but
Well, that's there. That's current. That's
again,
pretty
so
popular right now.
does.
Band-aid solutions. I mean, a lot of places are dredging soil or not soil, sand from the ocean floor to dump it back on the beaches as a way to keep their beach height higher than the surrounding, uh, the behind. I don't know. I guess in the case of the East Coast, the western houses, so the sea doesn't come up and over.
This is going to sound like a dumb question. Could we just blow enough holes into the earth to make enough zones to fill up with water?
I mean, are you asking if the human race has enough explosives? Because the answer is yes.
All right, Russia, America and Russia back together in the same team. Let's
So
go.
now we have to pick where our holes are gonna go.
Not it.
Nose goes.
Uh, and I got one more crazy idea for you. Extreme evaporation. So usually when you evaporate water, it produces just hydrogen and oxygen on a smaller scale. It goes up to the clouds, recycles. With extreme heat, you can break the bonds. We could add more oxygen and hydrogen into the world. Now, the hydrogen won't be a problem because based on its density, it would float up to the atmosphere and eventually make it to space. The oxygen should stay in our atmosphere, which is not a terrible idea, but it's also very volatile. But extreme evaporation. Use, God, what's it called? Electrostasis. What's it called when you like a hydrogen battery where you're using a cathode, anode, and electrolyte, well, pretty much a battery, to run a current and break up the water molecules into hydrogen, oxygen.
I have no idea.
Okay, but yeah, that's another dumb idea I came up with. It's just there's too much water, evaporate all the water into a point where it doesn't come back down. Or maybe with enough control, we could evaporate the water to where locations we want it to come down. But that's extreme environmental control, which I do not think we have the capability of doing yet.
Nope, I don't think so. I mean, I think we just have to adapt to a changing world, which we've been living in a changing world since modern history. So I think it's one of those things where in our time it seems like this pressing issue, but throughout human history we've been dealing with this problem. And so for right now, for our limited human scope of things, this is like the worst thing that's ever happened. Not the worst thing that's ever happened, but
worse than
not
Waterworld?
as bad as Waterworld, which
I don't know. I'm just shitting on that movie. I actually kind of enjoyed that movie as a kid.
It's just I think this is more a discussion on the inability of humans to accept that the world around them is changing than anything else.
Oh, yes. We are definitely scared of change. But perhaps the easiest solution, Nick, is we just buy a bunch of boats and we all just live on a boat.
Water world.
It's to me, it's not out of the realm of possibility. A lot of people just living on boats.
Well, you got anything else?
No, Nick, that's all the crazy solutions I have. Unfortunately, it's hard to come up with solutions because the oceans are massive, are absolutely massive. So to do anything to them requires so much effort and forethought to take care of.
And like it's such a massive, like you said, it's a large project. So anything you do has massive repercussions. So if we did build that dam, it would increase flooding or sea level rise outside of that area. So it would essentially just fuck over everyone else. So what are you going to do? I mean,
damned if you do, damned if you don't.
If you want to talk to us about sea level rise, hit us up on Instagram and YouTube. And Mike, what are you reading?
I am still reading Why We Sleep. I'm only a quarter of the way through. Again, still in my busy season, and I enjoy it, but I also fall asleep a lot, which is kind of the premise for this book. What about you, my friend? What else? What are you reading?
I am pretty much finished with the book Rising Seas by Vivian Gomez, just a book about sea level rise, which is what this episode is about. So now I don't know if I'll need to finish it since we're kind of done talking about it.
But are you enjoying it?
As an informational book, yes. It's not a book I'd read in my spare time.
Well, with that being said, Nick, tell us where you could find us reading some good books. And I am actually genuinely curious on other people's solutions for this problem, because this is a very complex problem and it affects kind of the entire world. So with that being said, hopefully I'll see you on a beachfront, but a beachfront that currently exists and won't exist in the future. Thank you all for listening.
Thanks for listening to the Backyard Philosophy Podcast. We rarely finish a podcast without missing a point we wanted to bring up, so let us know what we forgot. And if you have a topic you want us to talk about, let us know at Backyard Philosophy on Instagram